Hello, this video is about Miro and Frederick's proportional algorithm line follower. We use many of the same things as in the Bang Bang line follower. The same sensing mechanism, the same PWM controlled servos, and the same steering methods. As you can see in our code, we made a function to read the analog voltage input from the photoresist pin using the analog read function. In Arduino's analog read, it paints the input of 0 to 5 volts to an integer between 0 and 10.3. This function is the exact same in the Bang Bang algorithm. Generally, the integer values varied from around 550 over peak white to around 950 over black. In the Bang Bang algorithm, it was not extremely important to have consistent values all across the track, as long as the dark light threshold was in generally the desired location. As long as the threshold was decent, every other value could be unreliable, and it really wouldn't have mattered too much. That is not the case in a proportional line follower. So we had three important threshold values, one between what we'd arbitrarily consider dark and light, one between what we'd consider light and very light, and one between dark and very dark. So that means in terms of our code, there were four ranges for the Arduino to understand: very light, light, dark, and very dark. Based on what range the read value was in, the Arduino would output the assigned PWM voltage to the servo object using the servo write command. We'd take a reading from the sensor, and if it was within the two safe ranges, we subtracted the threshold value from the read value and divided it by 10. This new value, called dV, would be the way we'd increment the speeds of the two servos. For values that were closer to the extremes, the increment would be greater. It means it would drastically correct itself. If a read value is close to the dark light threshold, the increment would be smaller, so the servos would be closely aligned. In these simple calculations, you can see how when B is 650, the right servo speeds up and the left servo slows down to turn left correctness. When B is 750 in the black, the right servo slows down and the left speeds up to turn right and correct itself. As shown in the straightaway, when you start the car directly on the threshold, the speeds remain at the initial value and go straight. As it goes slightly off course, it starts to gently turn right, but not drastically like in the Bang. On the turns, however, the values of the reading and increment are harder to control, so there's generally a balance between it drastically correcting itself and it being cleanly on course, causing smooth curves. You can see in this left turn it starts choppy and smooths out. You can see the same on the right curve. And when you put all those concepts together, you get a line follower that should be able to cleanly follow the loop. However, what we discovered is that while it's not an issue if your sensor doesn't generate clean values in the Bang Bang, it is a necessity in the proportional. The Arduino is making key adjustments to the servo speeds every single iteration, and if the sensors are not giving reliable inputs, there's no way for it to cleanly follow the loop. Code worked as planned, but if we'd want the motion to be perfect, we'd have to create an LED sensor setup that wouldn't allow room lighting to have the effect that it did. Overall, though, despite the ruggedness of the path, it still follows the loop.